I'm looking at the input data for the isotonic regression model. X represents the predictor variable, and Y represents the response variable. I see X as 1, 2, 3, 4, 5, and Y as 1, 3, 2, 4, 5. Notice that Y is not strictly increasing. It dips from 3 down to 2 before increasing again. This is important because it shows that the relationship between X and Y isn't strictly linear. It's a nonlinear monotonic relationship. This is the predictor variable. It's a simple sequence of numbers, making it easy to visualize and understand the relationship between predictor and response variable Y. This is the response variable. It's a sequence of values that respond to the corresponding predictor values in X. It is crucial to note that Y isn't strictly increasing. It decreases at X equals 3, indicating a nonlinear relationship between X and Y. This is a machine learning algorithm designed to fit a non-decreasing, monotonic, curve to the input data. It doesn't assume a linear relationship. Instead, it finds the best fit that maintains the order of the data. It's smart, isn't it? I'm using the Sklearn library's isotonic regression to model a relationship that I suspect is monotonic, but not necessarily linear. Sklearn is a Python library and isotonic regression is a function which helps us to achieve that. This represents the predictions made by the isotonic regression model. It is not the same as Y. I'm investigating different possibilities for the output y_pred based on the properties of isotonic regression. Let's find out. This is your predictor variable, the input to the isotonic regression model. I see it's a simple sequence of numbers from 1 to 5. This is your response variable, the values you're trying to predict. Notice something interesting. It's not strictly increasing. It goes up, then down, then back up again. This is key for understanding why we're using isotonic regression. This is a machine learning model that I use to find the best fitting monotonic, either entirely non-increasing or entirely non-decreasing, relationship between X and Y. It's perfect when you suspect a relationship but aren't sure it's strictly linear. I apply this algorithm to the data to find the best possible monotonic curve that fits the data points. Think of it as drawing the least wiggly line that still generally follows the trend of the points. The output from the algorithm, y_pred, will always be a non-decreasing sequence. This means that the predicted values will either stay the same or increase as X increases. It will never decrease. The model might pass through some or all of the original Y values. It aims to find the best fit while maintaining monotonicity, but it doesn't guarantee passing through every single point. Crucially, this model doesn't assume that the relationship is a straight line. That's its strength. It can handle curved, monotonic relationships that linear models cannot. I see that we're using a simple sequence of numbers from 1 to 5 as our predictor variable, X. It's our input to the model. This represents the values we use to predict the response variable, Y. This is our response variable, Y. Notice that it isn't strictly increasing. It goes up, then down, then up again. This is important because it means the relationship isn't perfectly linear. The isotonic regression algorithm is a special type of regression that only fits relationships that increase or stay the same. It never decreases. The algorithm's job is to find the best fitting line through these points, but with a rule. The line must always go up or stay flat. It can't go down. That's what monotonic non-decreasing means. This is what the algorithm predicts for Y based on the X values. It's the result after applying the isotonic regression. Interpolation means the predicted values, y_pred, might exactly match some or all of the original Y values. It doesn't have to hit every point perfectly, but it aims to create a smooth, non-decreasing line through the data. This is the core question, testing my understanding of how isotonic regression works and what it produces. I need to analyze the properties of y_pred based on the algorithm's characteristics. This statement is asking, will y_pred always go up? The answer is likely no, because the original Y values aren't strictly increasing. Will y_pred always go up or stay flat? Since that's the fundamental rule of isotonic regression, this is probably true. This question is about whether the predicted values will match the original Y values precisely. It might not. It depends on the data and how well the algorithm fits it. Isotonic regression assumes that the relationship between x and y increases or stays the same. It doesn't require a straight line relationship. I'm looking at the input data. X values are 1, 2, 3, 4, and 5, while corresponding y values are 1, 3, 2, 4, and 5. Notice that the y values aren't strictly increasing, they go down from 3 to 2. This is important because it means a simple increasing line won't fit this data perfectly. This shows the predictor variable, x. It's a simple sequence of numbers from 1 to 5. We'll use this to predict y. This represents the response variable, y. This is what we want to predict using the x values. As I mentioned, this sequence isn't completely increasing. There's a dip in the middle. This is the algorithm I'll use to model the relationship between x and y. Isotonic means that it finds a relationship which is either non-decreasing, always going up or staying the same, or non-increasing, always going down or staying the same. It does not need to be a straight line. It can handle curves, as long as the curve always trends in one direction. This is the overall modeling technique I will use. The isotonic regression algorithm helps me find the best fitting non-decreasing, monotonic, curve through the data points given. This will be the result of applying the isotonic regression algorithm. It's the model's predictions for the y values, given the x values. These predictions will follow the non-decreasing pattern that isotonic regression enforces. This describes the nature of the output, y_pred. It will be a sequence of numbers that either stay the same or increase at each step. It can't decrease. It's a key feature of the isotonic regression model. Interpolation means the model's predicted values exactly match some or all of the original y values. In the case of isotonic regression, while it tries to find the closest fit, it does not guarantee to perfectly hit every single point in the original dataset. That depends on how well the data matches a monotonic curve. The isotonic regression model doesn't assume a straight line, linear, relationship between x and y. That's its strength. I can use it even if the relationship is curved, as long as it's always going up or staying the same, monotonic. I'm giving you the predictor variable, x, as 1, 2, 3, 4, 5, and the response variable, y, as 1, 3, 2, 4, 5. Notice that y isn't strictly increasing, it dips down from 3 to 2. This is important because it means we cannot assume a strictly increasing relationship. This is simply the input data for the predictor variable, representing some sequential or continuous measure. This algorithm finds the best fitting non-decreasing function to match the data. It finds a line that is always going up or staying flat, but never going down. This is the corresponding response variable for each value in x. Note the non-strictly increasing pattern. This is key to understanding what the isotonic regression will do. We're using a scikit-learn model called isotonic regression, a type of regression analysis that doesn't assume a linear relationship but still finds a monotonic, meaning always increasing or always decreasing, relationship between x and y. This will be the output of the isotonic regression model, the predicted y values for the input x values. The model will adjust y to create a monotonic sequence. The isotonic regression algorithm guarantees that the output will be a monotonic sequence. This means the values will never decrease. They'll either increase or stay the same from one point to the next. The model will try to pass through as many of the original y values as it can while still maintaining the monotonic non-decreasing property. It won't necessarily perfectly match all original values. This is the main question. It asks you to determine what properties the model's output will have. Will the output be always increasing? The initial y values are not, so the output can't be strictly increasing. This option describes the key property of the isotonic regression algorithm. The output will always either increase or stay the same. Will the output perfectly match all original y values? The algorithm strives for interpolation, but the exact result depends on the data. Is the model assuming a straight line? No, it's looking for a monotonic relationship, which could be linear but doesn't have to be. I see x as the predictor variable. It's a simple sequence of numbers, from 1 to 5. These numbers represent the independent variable. I'll use these values to predict the corresponding dependent variable, y. This is the response variable, y. Notice something interesting here. Unlike a perfectly increasing sequence, y fluctuates, decreasing from 3 to 2 before increasing again. This tells me the relationship between x and y might not be perfectly linear, but it may be monotonic, either increasing or decreasing. That's where the isotonic regression model comes in. I'm using the values of x and y, the predictor and response variables. This is my input data for the isotonic regression model. This refers to the isotonic regression function from the popular Python library, Sklearn. It's a machine learning tool designed to model monotonic relationships, which means relationships that are consistently either non-decreasing or non-increasing. It's perfect for this problem because y isn't perfectly increasing. This is where I actually use Sklearn's isotonic regression model. I'll use the x and y data I defined to train the model. The model will learn the underlying monotonic relationship between x and y. After fitting the model, I'll use it to make predictions. y_pred will contain the model's predictions for y, based on the values in x. This means the output will be a sequence of numbers that are either increasing or staying the same. There will be no decreasing values. This is the key property of isotonic regression. The model always ensures a non-decreasing output. I'm using a specific type of regression model called isotonic regression. Isotonic means that the model will always produce a non-decreasing output. I'm interested in the output, y_pred, which are the predictions that the model generates. Based on its properties, I know this will be a non-decreasing sequence.